Okay, lesson 9.1, our outcome. We're going to do a lot in this video, okay? I'm going to go through these first probably 3 bullets pretty quickly because the main idea is with the 4th bullet, multiplying and dividing powers. We will list the factors of numbers. We will identify prime and composite numbers. We will write the prime factorization of numbers, and then we will multiply and divide powers, okay? Let me get this. I want to change this actually. This is lesson 9.1 and lesson 9.2. Okay? That's why it's going to be so long. So, write down your outcome and buckle in your seatbelts because we're going to get started. Okay? Alright. What are factors of a number? What are factors of a number? Okay, here's a definition. Go ahead, pause the video, and write down the definition, and I'll talk about it on the other side. Alright, so a factor are numbers that evenly divide into a given number, okay? So you already know all of this, but we don't use the vocabulary. And now that we're algebra students, we need to use the vocabulary. We need to speak math talk. So the factors of 12. Well, without looking at this, what are numbers that go into 12 evenly? Okay, I'm hoping you're saying 2. I'm hoping you're saying 3 and 4 and maybe 6 and I said 2. Oh, and then what about 1? Does 1 go into 12 evenly? Yeah, how many times does it go in? It goes in 12. And there's a couple different ways you can do this. Let me grab a pen and show you. Look, 1 and 12. What do those multiply to be? What's 1 times 12? It's 12. What's 2 times 6? 12. What's 3 times 4? 12. So these are all factors. We know this. This is not new information to us, but we do need to know the word factors. Okay? So the other thing I want to show you, it can also be done in a tree. All right? So here we've set up a tree for you. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. So those are factors. Okay? So bullet number 1 taken care of. Let's move on. Factors of 5 and 12. So I want you to pause the video for a minute and write down what are numbers that go in evenly to 5 and what are numbers that go in evenly to 29. Pause. Alright, you're back now. 5. I hope you were saying the only 2 numbers that go into 5 are 1 and 5. Nothing else goes into that evenly. Okay? 29, we have the same problem. Okay? Well, there's a special name for that. If only the number 1 and the number itself, if those are the only two numbers that go into this number evenly, then it's called a prime number. Okay? It's prime. That the greatest number that goes into itself is 1 and itself. It has no other numbers. So I want you to think for a minute, what are some prime numbers that you know? Well, I hope you're saying 2, because what goes into 2? Just 1 and 2. What goes into 7? Just 1 and 7. We already said 5. Is 6 a prime number? No, because 2 and 3 go into that. Okay? Alright, let me get my tools. Next slide. So we've learned about prime numbers. Okay, now we need to talk about composite numbers. Alright? Here's another definition for you. Go ahead and pause it and talk about a composite and write down the definition. Alright, you're back. Composite numbers. Well, if prime numbers were numbers where only 1 in itself went into it, then a composite number must be something more like 12, where you have other numbers that can go into it. Okay? So, composite numbers are like 4 and 6 and 12 and 30. What goes into 4? Well, 1 and 4 go in there, but what else? 2 goes in there, so that's a composite number. 6, you've got 1 and 6, and then 2 and 3. 12, we already did 12, okay? And you can get the idea of what a composite number is. So, list the first 10 prime numbers after the prime number 2. So those are the ones that I was just going through. Prime numbers. You make a little list and see how many you can get, because I only show a couple here. Alright? There you go. What could we continue after this? Let's see. 8. No, that's not a prime number. That's a composite. 9. Nope, that's a composite, not a prime. 10, nope. 11, 11. Is that a prime number? Yes, we can add 11. 12, no, that's composite. 13, prime or composite? Prime, good. All right, you get the idea. I'm not going to waste our time here, okay? These are definitions that you were taught back in elementary school. Please just make sure you write them down and we start using them in our vocabulary in class. All right, here we go. Every composite number, okay, so let's highlight that. That's probably important. Every composite number can be written as the product. What does product mean? Hope you're saying multiplication. Okay. Every composite number can be written as the product of all prime numbers. Okay. Let's get some colors here. Okay, so let's look at 36. Okay. Prime or composite? Composite. Okay, so I'm going to put a little C there for composite because more numbers go into 36 than just 1 and 36. Okay, now for this prime factorization, okay, I like to do a factor tree, and I'm going to show you how that works here. Okay, so here's my factor tree. I put 36 at the top. Give me a prime number, like, I'm going to guide you here, 2. Okay, if I take 2, that guy's already prime. 2 times what gives me 36? 18, right? Do I have one prime number? Yep, I got one prime number. This guy right here. Okay, the 2. He's prime. So that's 1. Let me clone that dude. All right. Now, does 18 prime or composite? Ooh, composite. I got to keep going. All right. What times itself will give me 8? I'm not sorry, not times itself, but what 2 numbers multiply to give me 18? 2 and 9. Okay, very good. Do I have another prime number? Right there it is. There's my other prime. So I'm slowly getting there. I got to get to all primes. Can I break down 9? What times what gives me 9? Very good. 3 times 9. This guy is prime or composite. Is 3 prime or composite? It's prime. Very good. Did I end up with all primes? This branch ends in a prime. This branch ends in a prime. Oh, I finally got to where these 2 branches end in a prime number. So, the point is that 2 times 2 times 3 times 3 should give me 36. Okay? So I can fill that in here. 2 times 2 times 3 times 3. Well, let's test it out because I'm not sure I trust it. 2 times 2 is 4. 3 times 3 is 9. 9 times 4 is 36. Very good. Very good. That is called prime factorization. Taking a composite number and breaking it down into just prime numbers. Okay? So, here we go. Do you remember what an expression is in the form of x to the n power is called? Well, what does that look like? It looks like an exponent, okay? So these are exponents and powers, and that's what we're going to talk about here, okay? It's called a power, all right? This right here. And it is represented by the product you obtained when you use a number as a factor n times. All right, so the deal is, do we ever do 4 times 3? No, and that is a chicken move. You will get beat with chicken if you say that. 4 is not 4 times 3. It is 4 times 4 times 4. Okay, we're getting into the exponents. But I want to show you how it all works. So let's go back to what we already know about exponents. All right? I'm sorry, powers. I should use the correct terminology. Powers. We have 4 and 3. We know that the big number is the base, and we know that the little number is the exponent. Okay? The exponent tells us how many times to write the base. Okay? We're good with that. We don't need a review on that. All right? So here we go. 8 to the third. How would you write that? Don't you dare say it's 24, because it's not. Okay? It would be 8 times 8 times 8. Okay? I think we got that one. I'm going to move through this one. So here we go. That 36 is back. There was a whole reason that we did that. Okay? Do you remember what that 36 was when we did the prime factorization? It was 2 times 2 and 3 times 3. I want you to pause it right now And now that we've talked about powers, what do you think I'm going to do with these two numbers? What do you think? How do you think they could be rewritten? Oops, I don't want you looking at that. How do you think they could be rewritten using powers? Okay. All right, I'll show you now. 2 written 2 times is really what? 2 to the power of 2. It's 2 squared. What about 3 written 2 times? I could shorten that and write 3 squared. And that's the whole idea, is that we're able to break these numbers down. This is nothing new. You know about powers, you know about exponents, you know about prime factorization, but knowing their relationship with one another, okay? So why don't you try these? 4. Break down 4, do its prime factorization, and write it as an exponent, okay? I'm going to pause it, and you're going to do that, okay? And then I'm going to show you the answers. There you go. Okay? So here, let's look at this one at a time. Where's my highlighter? There it is. 4 ended up being 2 times 2, which could be written as 2 squared. 12 broke down to 2 times 2 times 3. Now, look at this. I can combine the 2's to be 2 squared, but can I do anything with that 3? Is there anybody to combine him with? No. Look at what turned out. 2 squared times 3. Okay? You can't clean that up any. There's no way to rewrite that. 30. Okay? It ended up being 2 times 3 times 5. If I do that. Okay? None of those combine. I can't make an exponent out of that. It doesn't work. And then 54. 2 times 3 times 3 times 3. The 3's, they can be combined into 3 cubed. Okay? And then that 2, he just gets left out here, 2 times this quantity, because he can't be combined with anybody else. Alright, moving on. Here we go. Now we're getting into the last bullet. This is the meat of all of it. Suppose you have the expression such as 2 to the third times 2 to the fifth. Okay? So that means I have to write 2 3 times, and then I have to write 2 to the fifth 5 times. 1, 2, 3, 4, 5. Well, I don't know about you, but there has got to be an easier way to write that. How many 2's did I write? To the 8th. So, when we multiplied, okay, I took 2 to the third, 1, 2, 3. Then I took 2 to the fifth, 1, 2, 3, 4, 5, 6, 7, 8. Really came out to be 2 to the 8th. I want you to think right now, look at that. Is there anything that you can maybe deduce from these exponents about how you got there? I'm not going to tell you the secret yet. Ready? Do the next one. 3 squared times 3 to the fourth. So I write 3 2 times, and then I write 3 4 times. 1, 2, 3, 4, 5, 6. The answer is 3 to the 6th. These are equal to each other. You got the idea of what the secret is? Here's what you need to write down. When you multiply powers with the same base, what do you do with the exponents? You add them. So, alright, write that out right now. When you multiply powers with the same base, what did we do with the exponents? You add the exponents. Okay? That's the rule for multiplying. Pause it, take it in for a minute, because now we have to look at division. Next. Oh, my bad. Property of multiplying powers. So look here. Go ahead and pause this and see how many of these you can do. This one definitely can do. This one maybe. This one looks pretty yucky, but I bet you can figure it out. So go ahead and pause and see if you can work your way through it. Bases are the same. Add the exponents. 8 to the 16th. Here we go. We have the x's are the same, so we can add those there. But what imaginary number is in front of that x? 1. What's 5 times 1? 5. And then you add the exponents. 6 plus 7 is 13. Now this one looks like a hot mess. Let me get my pen here. Alright. So we have the constants right here in the front, or I'm sorry, the coefficients. Okay, so we have 4 times negative 7. Alright, that's going to give us a number. Then I can do, okay, I have an a here and an a here. What's the power on this a? 1. So I have to do 1, and we're multiplying, so what do we do with the exponents? We add, so 1 plus 2 is 3. And then we have our b's, okay? B to the 6th and b to the 3rd. What do we do with the exponents? You add them, okay? All right, write it all out, nice and neat. Whew. Over here's the final answer. Let me make that bigger so you can see it. This one right here. 4 times negative 7, negative 28. A to the 1st, a to the 2nd, add them, a to the 3rd. B to the 6th, b to the 3rd, add them, b to the 9th. Done. Can I combine anybody else? No, I got numbers and variables. It's a hot mess, but that's the answer. If the bases are not the same, you just have to do each part individually. No shortcuts. 2 to the 4th, what is that answer? 3 to the 3rd, what is that answer? And then combine them. That's all. No shortcut if the bases are different. Division. All right, I'm almost done, I promise. Okay, whew, this is a long one, sorry. Dividing. When you divide two powers that have the same base, you subtract the exponents. So multiplying, addition, division, subtraction. They both mean the same. Subtract and divide mean that things get smaller. Multiply and add, things get bigger. Okay? So here we go. Base is the same, exponents. You keep the base, but subtract the exponents. 8 squared. Check it on your calculator. Okay? Here we go. Keep the base, subtract the exponents. This is a 5, and there's nothing there, so what does that mean? It's a 1. Very good. Here you go. 5 minus 1 is 4. 8 minus 3 is 5. Now there's one special case. I'm going to let you pause this. Write that down. I'm going to explain it in the next one. Pause it. Alright. You've read that, so I'm not going to waste your time reading that. Here you go. Bases are different. Okay? Exponents can be the same or different regardless. But if the bases are different, can I just subtract those exponents? No, it's not going to work. It's just old-fashioned grunt work. 5 to the 3rd power is 125. 3 to the 2nd power is 9. And then you just have to divide them, and it comes out to be 13.8. No fancy answer, none of that. It's just flat out what it is. I know this video was kind of long. I want you to take a minute, pause, if there's any section that you need to go back and look at, because we did cover factors, prime and composite numbers, prime factorization, and then we finally got to multiplying and dividing. This video does cover 2 lessons, however.